Okay? Now, before we go on to the next section, which would be a little bit of an introduction to P3, let's just do a real quick review of rules for exponents. See what you can remember. If I have x to the m times x to the n, when I multiply, what do I do with those exponents?
Add.
Beautiful, x to the m plus n. Thank you. Instead, if I have x to the m over x to the n, when I divide, what do I do to those exponents?
Subtract.
Subtract. That subtraction sometimes yields a difference of 0. What does x to the 0 equal?
1.
1. That difference sometimes gives me a negative. What does it, oh, I wanted an n and not a number there, I apologize. What does it mean when I have a negative exponent? Take the reciprocal, make a fraction. Instead, if I have x to the n and raise it to the m power, x to the n and raise it to the m power. When I raise a power to a power, I multiply the exponents. If I have a product and I raise it to a power, xy to the n, I raise each factor to that power. And if I have a fraction, a quotient, and I raise it to the power, I raise both the numerator and the denominator to the power. And again, with using those last three rules, you need to pay close attention to where there are parentheses. All right? If that's okay, when we hop now to do a little bit of introduction to the third homework, section 3, it looks like we're taking a great big leap into a totally different world. But you're going to find when we come back on Monday that where we're going is also very closely related to these exponent rules. Because the next place that we're going is we're going to start looking at radicals and rational expressions. I'm sorry, I didn't mean rational expressions. It's the other EXP word, rational exponents. So I'm guessing that everybody's used counting numbers as exponents before. I don't know if 0 as an exponent has been new for anybody. I don't know if negative exponents have been new for anybody. But over here, when I talk about rationals, remember rationals are ratios. And so we're going to eventually get to the point where we have, are you ready for this? Fractions in the exponents. And those are going to be related to our radicals, our square roots. So let's first look at the definition of, first of all, a square root. We're going to say that if A is equal to B squared, then B will equal the square root of A. B is referred to as the root. The symbol is referred to as a radical. And the A, what's underneath the radical is referred to as the radicand. For example, I'm going to put a real challenging one up here for you folks.
Wait, what does the word under A say?
Radicand. R-A-D-I-C-A-N-D. Do you want me to try to make that neater?
No, thank you.
It's hard writing with a stylus on a vertical surface. I should move the computer so it's horizontal. But I've noticed that if my hand touches the screen, it acts weird. So we're working on it. Is my penmanship almost neat enough? Is it getting any better as the semester progresses? I'm sort of getting used to writing like this. So example, what's the square root of 4?
2.
2. Why? Because 2 to the second equals 4. However, can I also say that the square root of 4 is equal to
1.
-2?
Oh.
Because if I take -2 and square it, don't I also get +4? And so we're going to say that every positive real number has 2 roots. One root is positive, and the other root is negative. And so if everything's got 2 answers, that's going to make some questions kind of ambiguous. Which do we mean? And so standard notation, if I just write the square root of A, that means I want what's called the principal root. Which is the positive root. If I put a negative sign out in front, that means that I want the negative root. And there's a symbol that looks like a plus sign kind of floating over a minus sign. Plus or minus the square root of A means I want to consider both roots. So for example, if I ask for plus or minus the square root of 36, it means I've got 2 answers. It's equal to 6 or -6. Another thing that you kind of need to be familiar with the idea is that the square root, principal root of A squared, A in parentheses squared, will always equal the absolute value of A. Wait, why am I throwing absolute value symbols in there? If I look at an example, if I want the absolute value, let's say of -3 squared, order of operations, I'd start on the inside. So that would give me the square root of 9. And because there's no minus sign or no plus or minus sign in front, that will give me +3. What if, another example, I ask for something like huge. You guys, you are supposed to start getting antsy and yelling at me. My phone tells me that it's 12:15, and aren't we supposed to end now?
Yeah, but I just love
Yeah.
love this class. I don't want it to end.
It's so entertaining.
You know what? I am on such a, well, I am officially a math geek and I enjoy this stuff. and I get on a roll and I lose track of time. And that's not fair to you, especially as some of you have another class to go to. So I am going to stop sharing my screen, stop recording,